Hello dear students, I am Savesh Kumar Bhati and today you can see my third video on double integration. In first two videos we have seen evaluation of double integration when limits are given and evaluation of double integration when region of integration is given. Today we will take the problems on change of the order. Now you can observe this double integration. Here we have variables x and y, and you can see that limits of inner integral, they are function of x. That means first we have to integrate with respect to y, and these 0 and 1 stand for limits of x. So we have to first integrate with respect to y, keeping x constant. But look at the function y divided by 1 plus y square under root of 1 minus x square minus y square. Here integration with respect to y first is more complicated than with respect to x first. Because when you integrate with respect to y first, you can see that in numerator there is y, in denominator there is a product of two function of y, and because of this the function is difficult to integrate with respect to y first even if x is a constant. Conversely, if we integrate with respect to x first, in that case y will be constant, so numerator y will be constant, and denominator 1 plus y square will be constant. Also in the square root 1 minus y square will be constant, and you can see that because numerator is constant, 1 plus y square is constant, they can be taken out and the integration became 1 divided by under root of constant minus x square, whose integration is standard and can be calculated very easily. In short, for this problem, integration with respect to y first is difficult, while for the same problem, integration with respect to x first is very easy. So what you should do here? First you have to sketch the region of integration from the limits of the given integration. You can see in last video we have obtained the limits of integration from region of integration. That means region of integration was given, and from region of integration we have obtained the limits of integration. Now here we have to go back, that is from the limits we have to obtain the region of integration. Here we have considered integration with respect to y first, that means vertical strip is considered here, and y0 and y is under root of 1 minus x square stands for the limit of y, means value of y at the bottom and top of the vertical strip. Now you know the y0 is x-axis, x is 0 is the y-axis, x equal to 1 represent a line. Now what does this equation y equal under root of 1 minus x square represents? So if you consider the equation y equal under root of 1 minus x square, taking square on both sides, you can have y square equal 1 minus x square, and from which you can have a very simple equation x square plus y square equal to 1, which is a circle having center at origin and radius is 1. So we can have this circle having center at the origin and radius is 1, and here because radius is 1, so this point will have the coordinate 1 comma 0, and this line will have equation x equal to 1. So we have to put the vertical strip in this figure. So bottom end is on y is 0, that is on x-axis, and top end is on circle, positive end of the circle, y equal under root of 1 minus x square, so it is placed here. Means we have to consider a vertical strip whose bottom end is on y-axis, bottom end is on x-axis, and top end touching the circle. Now What is significance of the limits x is 0 and x is 1? X equal to 0 represent starting of area, starting of the region, and x equal to 1 represent end of the region when you move this vertical strip from left to right. So when you x is 0 is your y-axis, that means you have to consider this vertical strip at y-axis, and we have to move this vertical strip from left to right so as to cover the region. And where to stop at x is 1. So this line has equation x equal to 1. That means this vertical strip starts from the line x is 0, that is y-axis, and stop moving on the line x equal to 1. And while doing this, the bottom make sure that bottom end and top end remains on same curve. Bottom end is on line x-axis and top end is on the circle. So in this way we obtain the region of integration. But just I explained that we need to change the order of integration. At present we have integration with respect to y first. Now we have to integrate with respect to x first. Means we have to consider horizontal strip in the same region. Horizontal strip in the same region. So this is the region, that is the positive area bounded by circle in the positive quadrant, and this is also same area bounded by circle in the positive quadrant. Now here we consider horizontal strip in the same region. Get the value of x at the left end. Left end is present on y-axis, and where x is 0, because equation of y-axis is x is 0. The right end is on the circle, and from equation of circle x square plus y square equal to 1, you can get the value of the x. This end actually stands for the positive value of x, and this other branch actually stands for negative value of x. So this end represent the positive value of x. You can see that this first figure represents integration with respect to y first, and the second figure represents integration with respect to x first. Means here region of integration is same but order is changed. Here in the first figure integration with respect to y first, so vertical strip is considered. In the second figure we have integration with respect to x first, so horizontal strip is considered. We obtain the value of x at the left end and right end from the curves. Left end is on y-axis, right hand is on circle, so obtain the value of x. And these two forms, lower integral, limits of lower integral and upper integral. So you can see that here this is the your integration, the function is there. First we are integrating with respect to x, so dx I written, and x is 0 and x is under root of 1 minus y square represent the value of x at the left hand and right hand of the horizontal strip. Now we have to find the limits of y. To find the limit of y, we have to move this horizontal strip from bottom to top so as to cover the entire region. When the strip is at bottom, that is at x-axis, there we have y 0, so this y equal to 0 forms a lower limit, and we have to move this horizontal strip from bottom to top, and we have to stop this movement at this point, and this point has a coordinate 0, 1, and that means you have to stop this moving this horizontal strip at the line y equal 1. So limit of y vary from y is 0 to y is 1. So same thing we have included here. Limit of y is 0 to y is 1. So here we have considered horizontal strip limit, and this x is 0 is the value at the left hand, x is under root of 1 minus y square is the value at the right is value of x at the right end, and we have to move this horizontal strip from the bottom, that is from the line y equal to 0, and stop the movement at y equal 1. You can see that here we have to integrate first with respect to x, so y will be constant, so this y and this 1 plus y square will be constant. They can be taken outside the integration. And by the way, here we have y is constant, so 1 minus y square will be constant, and let's take 1 minus y square as a square, so a became under root of 1 minus y square, and the integration became 1 by a square minus x square dx. And you can see that integration of this is standard, and integration of this became sine inverse of x by a. Then further you can put the value of a here, and the value of a is under root of 1 minus x square. Okay, now put x is this, then minus sign, then you put x is 0 here, because these are the limits of x. Now here we will find sine inverse of 1, and sine inverse of 1 is pi by 2, and sine inverse of 0 is 0. So in this way we obtain a single integral. And to solve this single integral, we have multiplied by 2 and divide by 2, because when you multiply by divide by 2, you can observe that the derivative of denominator became numerator. Here derivative of 1 plus y square is 2y, present in numerator. Apply this formula, integration of f dash of y divided by f of y dy is log of f of y. So integration of this became log of 1 plus y square. Limits of y are y is 0 to y is 1. First we put y is 1, then minus sign, and then you put y is 0. Like this we can, log 1 is 0, and we obtain the value of integration. So in this way we have changed the order of integration. And after understanding this example, you must practice on these examples. Evaluate the following integral by changing the order of integration. You can see that here in the first problem there is integration with respect to y first. Now we have to change the order, means we have to integrate with respect to x first. So from limit, obtain the region of integration, and then you change the order. If you observe third problem, limits of inner integral are function of y alone. That means there is an integration with respect to x first. But integration with respect to x first is difficult. Comparatively, integration with respect to y first is very easy, because at that time x will be constant. So in this problem also you can change the order of integration. Procedure is same. First, from the limits, find the region of integration. There we have a horizontal strip, and in the same region you can consider a vertical strip and carry out integration with respect to y first. At that time e raised to x square remain constant. You can solve these problems, and you can verify your answers also, because answers are available here. And after this problem there is another type. We have given the problem, and in problem function is not mentioned here, but just asked to change the order of integration. Look at this example number 2. We have limits of inner integral, they are function of x, means first integration with respect to y. Now we have to change the order of integration. So first we have to carry out integration with respect to x. So from the region of integration, from limits find the region, from region you can change the order. Thank you very much. This is my fourth video. So we prepare one more video on double integration. Thank you very much.